All right, we're still in chapter 3. However, we're going to revisit slope. And slope, I say revisit because slope is a concept that you learned in algebra. So we're going to do this in geometry also in our chapter 3 here. So just let's remind ourselves about a few things about slope. So slope just measures the steepness of a line. Does it have a really steep incline to it, or does it have kind of a gradual incline to it? And that's what we mean by measuring slope. We're just saying if it's steep or is it kind of gradual. We also talk about whether or not there's an incline at all and whether we're heading uphill or downhill. So we have these silly pictures here with the people on them, and I don't know why, but I always think about, when I think about slope, I think about walking up a hill. All right? So in the first picture, it says that's a picture of a positive slope because that person is clearly walking uphill. And you're going to see these arrows down below, right here, these little arrows down below. Those are trying to tell you that we always read our slope from left to right. And so if we're deciding if a slope is positive versus negative, you want to look at it from left to right. So if you were starting at the bottom here on the left and moving to the right, we would be heading uphill. Whereas in the next picture, as we move again from left to right, if we're going this way, the person starts at the top of the hill at the left and moves down to the bottom of the hill once we get all the way to the right. So that's considered a negative slope. In the next picture, there's actually a zero slope. You can walk on a horizontal line, right? We could walk on a horizontal path, a path with no incline. But if there's no incline to it, it's just like maybe kind of walking on a flat sidewalk, that's considered a zero slope. So as this person walks from left to right, there's no incline, so that's called a zero slope. And then finally, we can have an undefined slope. Think about the fact that there's no way you could walk up a hill or up a wall, something that's completely vertical like that. And that's why there's no person on there, because it's not even possible to walk that. So as you move from left to right, you're really not going anywhere because you're trying to go straight up. And so that's considered an undefined slope. So again, a positive slope is if you're heading uphill. A negative slope is heading downhill. A zero slope is if you're walking completely horizontal. And an undefined slope is, well, you can't walk that, right? Because nobody can walk a vertical hill. Nobody can go straight up something vertical. And so that's how you want to think of slope. All right, underneath it said always read your slope from left to right. So again, that's what those little arrows were about. That's how we should interpret our slope from left to right. And there's a slope formula that you learned in algebra. And it said it's y2 minus y1 over x2 minus x1. Not sure if you remember that, but that is a formula that you learned. And so slope, when we're dealing with an equation, is going to have a little m. So we're going to talk about it later in these notes. We're going to say y equals mx plus b. And the m stands for slope. We also sometimes say it is the rise over the run, remembering the rise would be your y values, right? And your run would be your x values. And again, the formula is just subtract your y's on the top and subtract your x's on the bottom. And I have this note up above that says subtract your x values in the same order you subtract your y values. So just, we'll talk about that when we get to the ordered pairs, but it honestly doesn't matter if you say y1 minus y2 over x1 minus x2. That's the same thing as saying y2 minus 1 is over x2 minus x1. And again, I'll talk about that later when we do the slope formula. But there really is no one correct way of subtracting your values as long as you subtract them in the same order on the top and the bottom. All right, but let's start off with finding slope from some graphs. So when we have a graph, we could use the slope formula. We could label the A and the B with coordinates, and we could use the slope formula. But I think it's easier just to count squares. So we're going to save the slope formula for example 2. So in example 1, if you counted your rise over your run, again, remember that your slope has the variable m, and we think of it as rise over run, right? Especially when we're dealing with a graph and we're just going to count squares. And so as you traveled from A to B, remember you're supposed to be traveling in this direction. So as you traveled from A to B, you went up 2, right? You went up 2 squares. So your rise was 2. and you went over 1, 2, 3, 4, 5 squares. So there's 5 squares in the run direction. And so our slope then is 2 over 5. Again, really important that you remember to do your rise first and your run in the denominator, because we want our y values over our x values. All right, if we look at B, they're asking you what's the slope of line CD, and hopefully just by looking at it, you're going to say, well, it's going to be an undefined slope because I can't walk up a vertical hill. But another way, again, to look at it is to think of it as your rise over your run. So as you move from point C to point D, which again you wouldn't be able to do, right? There's no way you're going to be able to go straight up a hill if it was a vertical hill. So what did we rise? We rose 1, 2, 3, 4, 5, 6, 7, 8. So we went, our rise was 8. Even though, right, it's not really possible. Our run is 0. We never went anywhere in the x direction. So if you really were trying to calculate it by counting squares, you'd get 8 over 0. And there's a little trick for remembering that dividing by 0 is not possible. So if you want to divide by 0, that's a no-no. So think of that as N-O, no, you can't do that. You're never allowed to divide by 0 in math. And so that's why we say the slope is undefined. Because if you even tried to do the rise over run formula, you would end up trying to divide by 0, and you're not allowed to divide by 0 in math. Now, I would be absolutely fine with you just looking at the line and telling me it's undefined. You don't have to go through the 8 over 0 calculation. You could just tell me it's undefined, and that would be fine. Same with the next one for C. You don't have to go over the rise over run calculation. You hopefully would just look at it and tell me the slope is 0. But if we do look at the calculation and say, well, what would the rise over run be? If we tried to calculate rise over run by counting squares, what would happen? So if we tried to rise as we move from E to F, we see that we don't. We never go in the up direction. We only go in the X direction, the horizontal direction. And so our rise is 0. We never rose anywhere. We never went anywhere in the Y direction. But we ran 1, 2, 3. So that gives me 0 over 3. A little trick for remembering, is it okay to divide by 0? We said was to say no, but is it okay to have a 0 on the top? Think of the word okay. It is okay to have a 0 on the top. It is a no-no to have a 0 on the bottom. So that hopefully will tell you when is the answer 0 versus when is it undefined. It's undefined when it's a no-no. It is a 0 when we have a 0 in the numerator. So again, I don't need you to go through the whole rise over run calculation for horizontal and vertical lines. Hopefully you just memorize that vertical lines are undefined and horizontal lines are 0. But the next one, we would have to go through the calculation. So we want to, again, think in terms of rise over run by counting squares. Again, we want to travel only in the left to right direction. So we would be thinking of what happens all the way at the left. Well, all the way at the left, we're starting at H. And so this time we're going down 1, 2, 3, 4. 4. Sorry, I almost went too far. 1, 2, 3, 4. Yeah, we went down 4 squares. And so our rise, this time we didn't really rise, we went down. So we're going to call that a -4. So if you're not rising but you're going down, that's going to be negative. And then we ran 1, 2, 3, 4. So we went down 4 and to the right 4. And again, if you're going to go down instead of up, you're going to call that a negative rise. If we box that as the answer, the only problem with that answer is it should be simplified. So anytime you can simplify your answer, you should. And -4 divided by 4 is -1. All right. So that's your answer for that downhill slope there. Okay, so anytime you're dealing with graphs, which on tonight's homework I gave you some graphs, think of it as rise over run and just count your squares. Well, what if we don't give you a graph, though? If we don't give you a graph, then we're going to have to use the slope formula. So up above, I told you the slope formula was subtract your y's on the top, subtract your x's on the bottom. And I told you it really doesn't matter which one you subtract first on the top as long as you do that same thing on the bottom. So we could say it is y2 minus y1 over x2 minus x1, or we could reverse that. So what I'm saying here is you could take the 2 minus the negative 2 and call this one your y2 and this one your y1. Or you could take the negative 2 minus 2. It doesn't really matter. But I know most of you are familiar with this first formula here, so we're going to stick with that, okay? So we'll call this first ordered pair x1, y1, and the second one x2, y2. And so we're going to subtract our y's on the top, and we're going to do 2 minus a negative 2. And on the bottom, we're going to subtract our x's. So since we started with the second ordered pair on the top, we got to do the same thing on the bottom. So negative 1 minus 4. Now that can be tricky because of all those negatives, and you got to really be careful with signs when you're doing slope. So on the top, we have 2 minus a negative 2. Remember what that really means. That really means plus a positive, right? And so we're going to get on the top a positive 2 and another positive 2, which gives me a positive 4. On the bottom, we're going to get a negative 5. And you would be able to use your calculator, so if you want to make the calculator do the subtraction, that's fine too. As far as that negative goes, you can box this. This is 100% fine to box this. I would mark that correct. But an answer key is going to take that negative sign and stick it right in front of the fraction bar. So I'm just going to put the word or here. This is what you would see like on an official answer key from a book. You would see that negative right in front of the fraction bar, because the fraction is what's considered negative, not the numerator or denominator is not what we consider negative. We consider the whole thing negative, which just means the slope is a downhill slope. All right, let's do a couple more. So for B, we're going to call this one x1, y1. We're going to call this one x2, y2. We're going to subtract our y's on the top. So we're going to take 3 minus 1 on the top. We're going to subtract our x's on the bottom, 4 minus 2 on the bottom. When we do that subtraction on the top, we get a 2. When we do that subtraction on the bottom, we get a 2. Again, don't box that because it can be simplified. So 2 over 2 is just 1. All right. In the next one, if we call the first one x1 and the second one y1, and then the next one x2 and y2, we would subtract the 3 minus the 0 on the top and the 2 minus 2 on the bottom. Again, I subtracted my y's on the top, my x's on the bottom. I'm going to get 3 over 0 because 2 minus 2 is 0. And again, that's a no-no, right? Think of that no versus okay. That is a no. And so that means you can't stop there. You have to tell me that you understand that this thing is equal to undefined. We don't want to just leave it as 3 over 0. You have to say the word undefined. All right. All right, last one. Our slope is going to be, if we subtract our y's on the top, again, let me label those real quick, x1, y1, and x2, y2. If we subtract our y's on top, we'll do 5 minus 5. And then on the bottom, we'll do our x's. We'll do negative 4 minus 3. On the top, we get a 0. On the bottom, we get a negative 7. 0 divided by anything is just 0. And remember, we knew that was okay to have a 0 on the top. We don't have to call that one undefined. All right, again, that one was a no. Okay, so that's using the slope formula. What I have highlighted in yellow there, we're going to subtract the y's on the top, the x's on the bottom if we do not have a picture of a graph. The last thing we're going to remind you about is what happens if they give you an equation instead. So what we want to make sure is that we have our equations in what's called slope-intercept form, or y equals mx plus b form. If you have them in that form, then of course the m is where your slope is happening. So the first one, that's exactly what they did. They gave it to me in y equals mx plus b form. So this number right here is my m, right? That's my m. So my m is equal to negative 1/2. Let's do it again. The next one, is it in y equals mx plus b form? And again, that means is the y by itself with nothing in front of it and everything else is off to the other side. Yep, that's what's happening here. So that 4 that's in front of that x, that is your slope. And so my m just equals 4. Make sure you do not tell me that your m is equal to 4x. Your m is only equal to the number. It does not include the variable. All right, in the next one, we want the number in front of x, but this time there isn't one. So remember, that means there's an invisible 1 here. And so that's what your slope is going to be. So my slope is going to be equal to that invisible 1. Anytime you have an x that looks like it has nothing in front of it, it really has a 1 in front of it. And in D, we have a problem. We're not written in slope-intercept form. So we have to isolate our y. So again, you've done this in Algebra 1, so let me remind you what to do here. To isolate our y, we're going to get rid of 2x by adding 2x to both sides. That means it cancels off of the left side, and we're ending up with 3y equals. On the other side, I'm going to write my x term first because I'm trying to write it in mx plus b form. So I'm going to write 2x plus 4. And then I'm going to divide by 3 because I'm trying to isolate my y. So if I divide everything by 3, I end up getting y equals 2/3 x plus 4/3. Now this right here, these two things are the same, right? It's okay to have 2x over 3, or it's okay to have 2/3 with an x next to it. Those mean the same thing, all right? And so I like to write it as 2/3 x because that way it's really obvious what number's in front of x. Again, that's going to be my slope. So my slope is equal to 2/3. All right, so if you have an equation, the important thing to remember is it has to be in y equals mx plus b form. Again, that means that the y is isolated and nothing's in front of it and everything else is off to the other side. Once it's in that form, then whatever's in front of your x is your slope. So in summary down here, what did we learn to do? We learned to find slope of a line from a graph by counting squares, a set of ordered pairs by using the slope formula in example 2, and in example 3 we learned that we could write the equation in y equals mx plus b form, and the slope will be the number in front of x. This is all a review from algebra, so hopefully you find the homework easy too.